Last time, we walked through 5 cascading failures triggered by the vibe coding boom, power grids buckling, insurance markets breaking, open source volunteers drowning in AI-generated noise. If you haven't seen that one, it'll give you the foundation for what we're about to do here. Because all of those failures don't lead to one future. They lead to 4 very different ones. And which one actually shows up depends on 2 things nobody can predict with certainty right now. In our MEIA analysis, that's multidimensional event impact analysis, the framework we use to map how a single disruption cascades across physical, economic, security, and social systems, we built a scenario matrix around the 2 uncertainties that matter most. The first is where the AI actually runs. Does it stay concentrated inside the big cloud providers, Amazon, Google, Microsoft, where there's visibility, telemetry, and at least some regulatory reach? Or does it get pushed out to local devices, your laptop, your phone, a server sitting in a closet where nobody's watching? The second is how many AI models dominate the market. Do we end up with 3 or 4 foundational models that everyone uses, creating a kind of monoculture? Or does the open source ecosystem fragment into hundreds of diverse models, each producing wildly different code? You cross those 2 uncertainties, and you get 4 quadrants, 4 possible futures. Each one breaks in a different way, benefits different players, and demands a completely different response. Let's walk through them. The first, and the one our analysis currently flags as most likely at around 30%, we call monitored monoculture. A handful of dominant AI models running centralized in the cloud. The providers enforce security telemetry at scale. Vulnerabilities are standardized, which means they're visible and patchable. On paper, this sounds like the safest outcome. And in some ways it is. If a flaw is found, a cloud provider can push a fix globally in seconds. But it has a blind spot that carries directly over from what we covered last time. The cloud containers will still perfectly execute broken logic. You can patch a known vulnerability across 1 million servers instantly. You cannot patch a hallucinated business logic flaw that nobody recognizes as a flaw in the first place. The infrastructure works. The thinking inside it doesn't. Same problem, just at massive, centralized scale. The early signals for this future are pretty clear. Watch for major cloud providers mandating zero trust for all enterprise AI workloads. Watch for insurance companies refusing to underwrite anything hosted outside those environments. If that's what you're seeing in your industry right now, this is probably the quadrant you're heading into. The second quadrant is the one that concerns us most. We call it the dark edge. It sits at 25% probability, but it carries the highest consequence score in the entire matrix. And our analysis flags it as deserving more strategic attention than that number alone suggests. Here's how it unfolds. Cloud compute gets too expensive. Grid throttling, energy rationing, the compute winter we talked about last time. And the market responds the way it always has when centralized compute becomes constrained. It decentralizes. Mainframes gave way to PCs. On-premise servers gave way to cloud. This time, cloud gives way to edge. Consumer chips from Apple, Qualcomm, Samsung start running serious language models directly on the device. Sounds like a win for privacy and independence. The problem is what you lose. In a centralized model, there's visibility. Someone finds a vulnerability, and the provider can respond globally. In the dark edge, you have billions of fragmented devices running slightly different versions of the same dominant models, generating code in environments that corporate IT cannot see, regulators cannot reach, and nobody is monitoring. The monoculture makes the exploits standardized. The edge makes them invisible. That combination, standardized vulnerabilities in unmonitored terrain, is the worst-case intersection in our matrix. The signal to watch is hardware. When consumer devices ship with processors capable of running 8 billion parameter models locally, and cloud compute prices have climbed 200% or more, you're entering this quadrant. The third future we call the Glass Monolith. 20% probability. AI stays centralized in the cloud, but the model ecosystem fragments. Hundreds of diverse open-source models running on the same hyperscaler infrastructure. The chaotic diversity resists automated exploitation, which is genuinely useful, but the cloud providers can't standardize patches for code they can't predict. Every deployment is different. Every failure is unique. Grid stress stays acute because all that diverse compute is still physically concentrated in the same data center corridors in Northern Virginia and Ireland. The trigger signal for this one is when the open-source model ecosystem exceeds 500 production-grade models, while cloud hosting still dominates total inference workloads. Lots of diversity, but all of it sitting in the same few buildings. The fourth we call the chaotic frontier. Also 25%. This is maximum entropy, minimum governance. Diverse models running on local devices everywhere. No monoculture for attackers to exploit at scale, but also no centralized entity with any visibility into what's happening. Maintainers overwhelmed, regulators blind. The risk isn't concentrated anywhere. It's diffuse and basically unmanageable. The signal here is when no single model holds more than 15% market share and maintainer attrition in critical open-source libraries exceeds 30% per year. If both of those are true simultaneously, you're in the chaotic frontier. Now, and this is the part we think matters most, each of these futures demands a fundamentally different strategic response. The wrong posture for the wrong quadrant isn't just inefficient, it's dangerous. Under monitored monoculture, the move is application layer auditing. Accept the cloud consolidation, but invest heavily in people who can verify business logic at the container boundary. The infrastructure will not save you from a hallucinated API. Under the dark edge, the move is provenance enforcement. Cryptographic signing for every piece of AI-generated code, regardless of where it was produced. Organizations that wait for regulatory frameworks to catch up to edge proliferation will be fully exposed to the highest risk quadrant in this matrix. Under the chaotic frontier, the move is immediate. Fund open source maintainers. Treat their burnout as a material supply chain risk. The cost of supporting 50 maintainers is trivial compared to the cost of a frozen OpenSSL or curl library that half the internet depends on. And under the Glass Monolith, if the trigger fires, public confirmation that a major foundational model has been compromised through training data poisoning, the playbook shrinks to hours, not months. Sever critical systems from public AI APIs. Fall back to air-gapped environments. Accept the productivity hit. Survival comes first. We also stress-tested the entire matrix against 4 wildcards that could invalidate the framework altogether. A major AI lab open-sourcing its frontier model overnight, collapsing the monoculture axis. A hardware breakthrough that drops compute costs by 10 times, making the energy constraint irrelevant. A catastrophic real-world incident caused by vibe-coded infrastructure, triggering a global AI moratorium. Or a research breakthrough in provably correct AI code generation, which would partially resolve the verification problem at the heart of all of this. Each is low probability, 3 to 20%, but any one of them redraws the entire map. The honest assessment is that none of these futures is clean. Every quadrant carries serious risk. The difference is in the type of risk, who bears it, and whether you can see it coming. Our analysis gives the strongest trend signal to monitored monoculture, but the dark edge deserves disproportionate attention. It's the quadrant where the threat becomes invisible, and invisible threats are the ones that do the most damage before anyone responds. There's one more layer to all of this that we haven't touched yet, and it might end up being the most consequential of anything we've covered. Everything we've discussed so far assumes the legal system can handle what's coming. But think about it. Who's actually liable when AI writes the code? Not the company, they didn't write it. Not the AI lab, they didn't deploy it. Not the developer, they just typed a prompt. That question is about to break the entire software liability framework wide open. Next time, we dig into that.